Next topic is optoelectronic devices. Opto means just related to the light. Then what is optoelectronic? Optoelectronic devices. Optoelectronic devices are the semiconductor diodes which converts either light energy into electrical energy, or light energy into electricity, or vice versa, electricity into light. And there are three optoelectronic devices we are studying in your syllabus. The first one is photodiode. Photodiode is the diode which converts light energy into electrical energy. Photo means light again. And second one, LED. LED means light emitting diode. It converts electrical energy into light energy. So both are exactly reverse. And next one is solar cell. All of you know what is solar cell. Solar cell is again a diode which converts solar energy into the electrical energy. Remember. Next topic is the first one, that is called as photodiode. What is photodiode? The photodiode is a diode that converts light energy or photon energy into electrical energy. Here the diagram is there for that. You can see. This is the symbol of photodiode. This is the normal diode and on which the photon is falling. Photon or light is falling on it. And here the circuit diagram, you can see the photodiode. This is just a diode, P side and N side, and this layer is called as depletion layer. And this diode is said to be photodiode. We have to connect it in reverse bias. You can see the P type is connected to the negative of the battery and inside is connected to the positive of the battery. Now, if you connect like this, what happens? Only the minority charge carriers can flow in it, and that produces very tiny current. That is of the order of nanoamps or microamps. Less than that, the current will be produced, and there is no use from that. Now, when the light is falling on it, light is falling on this particular diode, what happens? There is a generation of holes and electrons in it. There is a generation of holes and electrons in it. And these electrons produced, they will be attracted towards the positive terminal of the battery, and these holes are attracted towards the negative potential of the battery. As a result of that, that flow of charges produces the electrical current in it. And this electrical produced depends on the amount of light falling on it. If there is no light falling on it, very tiny current produces due to minority charge carriers, and as the light falling on it increases, the more current will flow in an external circuit. Next, we will see the VI characteristic of photodiode. Voltage and current characteristic. How the voltage and current varies. Okay, here the diagram is there. So we have taken in VI characteristic the voltage along x-axis side and current along y-axis side. So here this is completely taken in a third quadrant. That means it is reverse bias. It is operating in reverse bias. Now, when there is no light is falling on the diode, very tiny current flowing in it, and that is because of minority carriers in P and N side. And that particular current is called as dark current. That is called as dark current. As the light intensity increases, then what happens? The current in this diode increases. Why? As the light falling on it, there is a generation of holes and electrons. Electrons and holes will be generated, and these electrons flow towards positive potential of the battery, and holes flow towards the negative potential of the battery, and that produces more current. So more current you are going to get. So as the incident light intensity increases, the current also increases. Here I1, I2, I3 are the intensity of light. I3 is greater than I2 is greater than I1. So light intensity increases, the current also increases in a photodiode. Next, what are the uses of this photodiode? One by one we will see. The first one, the first use is that it is used in optical fiber communication. Then what is optical fiber communication? And this optical fiber communication is the common application of photodiode as well as LED. We will see one by one. So optical fiber communication, I will explain it now. Suppose I am just speaking here. I am producing the sound, and this sound in front of the mic. This is the mic I have. I am speaking in front of the mic. What the mic will do? The work of mic we are using. The work of the mic is this mic converts this sound energy into the electrical energy. So whatever the sound I am producing here, sound energy, and that will be converted into electricity. So that is the work of the mic. And this electricity is now connected to the LED bulb. This is the LED bulb we have. So whatever I am speaking now, the variation is producing in the form of light. If I am not speaking, I stopped, then there is no light. If I am start speaking, there is a fluctuation of light here you can see. Now this light produced is allowed to pass into such type of channel. This is optical fiber channel. This is the optical fibers we have made up of glass. It is made up of glass or quartz. When the light is producing from the LED, that LED pass into the optical fiber in zigzag path. Now here the receiver is there, maybe after thousands of kilometer, so it passes through the optical fiber, and somewhere here a receiver is there, and that receiver receives it. How they will receive? They will receive it in the form of light only. The light is coming out, and that light is actually falling on a diode. Which diode? This is a photodiode, and this photodiode will convert this light energy into the electrical energy. We are going to get the electrical energy here, and this electrical energy coming is connected to the load speaker, and whatever I am talking here I can able to receive it here. So somebody is speaking here, I can receive it. So through the optical fiber, and such communication is called as optical fiber communication. Here we are using the photodiode. This is the photodiode, and here I am using LED to convert sound energy into electrical energy, and electrical energy is converted into light energy. So electrical energy can be converted into light energy by using LED. So this communication is called as optical fiber communication. And the next application is used in remote control receivers in TV. So we know this is the first application we studied, and the second application is in remote controlled receivers in TV. We know that here there is a TV. So this is a TV here, and somebody is sitting here. Somebody is sitting. Now I want to change the channel here on a TV. I want to change the channel on a TV. How to change the channel? By sitting here. What I have to do? I have to use the remote. Right? This is the remote. I have to press some button over here. Then what happens? There is a change in channel. What is happening here in this process? Here, if somebody is pressing the button, what happens? Here on the top of this remote, there is again LED, and this LED is infrared LED. By the moment you press the button, what happens? That produces the light, and that light is IR radiation. So it is invisible for us, and that light goes, IR radiation goes and reach the TV. In the TV, what is there? There is a photodiode again. Here there is a photodiode, and this photodiode will react for this light. When a light is falling on it, what happens? This diode converts light energy into the electrical energy. So that electricity pass into the TV and react for this particular button, whatever we pressed. So it is used in receiver here. What we are using here? Photodiodes. And what here we are using in a remote, and this is again LED. So LED, and here it is photodiode. Remember, this is again a common application. This is the first common application for photodiode and LED, and this is second common application for diode as well as photodiode as well as light emitting diode LED. So remember at least two if they ask in the exam. These two are common application of photodiode as well as LED. Next application we will see. The next one is, it is used in burglar alarm. So photodiodes are used in burglar alarm. So what is that burglar alarm? So third one, burglar alarm. Now you would have watched maybe in a company. Here there is a door, and when a person is passing, the person is a burglar, he is passing through the through this door. He is passing through the door. Here they kept the LED first, and what this LED will do, it produces continuous IR light, infrared radiation it produces. It is invisible for the burglar who is entering it. And this side they were placing a photodiode. Here this side, photodiode. And this photodiode is continuously receiving the light from LED. So by the moment burglar enters in it, what happens? The light will not receive by the photodiode for some time. At that time what happens? There is alarm here which is connected to the photodiode that rings. So when burglar enters, by the moment he enters, there is light which is not falling on it. When light is not falling on it, there is a less current flowing on it, and that activates the alarm. That alarm rings. This is again a common use of LED as well as photodiode. Remember. And the next use is that it is used in note counting machine in the bank. In a bank, we saw, no, whenever we give the note some notes, they will count it through the machine. Again, here also they are using the photo diodes.